Welcome back at Ask Professor. I really enjoyed your questions, also particular focus on your own cases or own problems from your own country. That's very good because I like to push you to be active and also to stay on the line per week, so you have this interaction with each other as students together and also with us, so we have a nice phase together. So let's start with the first questions. The first question was about how to weld different grades of rail to each other. That's a good question. It looks very easy and we can do it in practice, but it is really a problem, because it could be a problem when you have different ingredients of the material. And then you have to make a compromise, because welding two grades to each other, the hardness is different, all the characteristics are different, so also the toughness. How to make this balanced, and therefore you need a really unique portion. So you can do it with thermal welding. It's possible, but you have to be compromised, and it's a balance. And then you have to make the choice. What do you prefer? Do you like to have more toughness, or do you like to have hardness? That's really the discussion you need, and therefore the manufacturers always discuss with the infra manager what are the most important priorities. You don't accept any compromises, and that's up to you. Another nice question is more about the future. What about 3D printing? Is it possible to make parts or spare parts in the railway business? Yes, of course, but you have to be aware that you need high quality of materials to make these 3D printing parts. So what I tried, and also what we do and investigate at the university, is can we make 3D printing by steel? And I think that's the only answer, because when you talk about real assets parts or spare parts, it's always steel or concrete, or so you need to have the same quality of material characteristics. So plastics, maybe you can do it inside the signaling part, but really on the assets in the infra, so on the civil side, I think you have to make a 3D printing model or ID, just focus on the same material characteristics and then do it by 3D. It's possible. We also have some first prototypes, so looks very promising. A question about what kind of problems or where you could get when you have, for example, a train running in a curve but with a lower speed. And that's what happens, for example, in our high-speed line, because in a high-speed line was designed for 300 kilometers an hour, but the trains were not able to manufacture it on time, and therefore we need another train running on the same track. And when it is slab track, you cannot change the alignments, and also not the problems in the curves, you could say. So you had a lower speed while the curve was designed for a higher speed, and that means that you get problems in the inner circle, in the inner leg of the curve, and there you get really strange problems. Head checking, for example. Normally you get it on the outside, on the outer curve, on the outer leg, and now you get head checking in the inner leg, because the rail match, the system approach is not right, and therefore you get this kind of problems. So that's a possibility. So when you change parameters, you get problems, but also when you have not well maintained parameters, you also get problems. So you have to be really aware what are you doing, and that's the full system approach you need as an engineer. When you look at different rail profiles, not only the material but also the profile, so you have a different height, for example, or different shape, how can you connect, how can you weld this? And therefore you need a transition rail, transition type, you could say. On one leg it's exactly the same as the other material and the profile, and also on the other side, and in between you have a very smooth transition to spray out the forces and the energy in a smooth way. And that's pure design, that's engineering, and therefore you need a transition, for example, in 20 centimeters or more. Different, it's depending how big the differences are of the profiles, but you need a transition profile, and that one you weld just with a thermal weld, one-to-one on one side, and also on the other side one-to-one or flat butt welding. But in principle, in between you need a special design to overcome the differences in profile. And here you have the same story. It's the train is not a kangaroo, not jumping. You need a flat plane, no jumpings or differences. So the geometry on top, on the running band, must be smoothly, otherwise you get really problems, especially on this special transition. So be careful. In the forum you also have nice discussions, and I like to pick out some of them. One was about how to do this data management and how to collect from on running operational trains, to do some analysis or other things, to do directly data coming out of the track, and what kind of parameters you zoom in and how to do it. As I told before, we have our CTO, our measurement coach. We do all kinds of sensors, we test this, we like to make it proven technology, and then we see, okay, what do you really need? That's question one. What are the parameters to steer all my maintenance? Because therefore you need a sensor or to do some actions to make it clear what do you like to measure. And then you make this, you try to make a sensor, and then you try to copy paste it on a regular train. What we do in Holland, we try to make a program to say, okay, how big is the full infra, how much trains we have, and how they are planned. And we think in Holland, for example, with 7,000 kilometers, we can manage with 20 daily equipped trains to measure all kinds of data. Especially what are the focus on these parameters is mainly alignment, geometry. So the dynamics, because when it is not flat, you get really this kangaroo effect, and then you get problems, and they're getting more severe when you wait. So that's a trigger to do maintenance. But also sinking track, for example. What about the geo condition? What about the clips and the sleepers? And also the ballast. So that in common, we try to make sensors, try to catch the right triggers out of this data, mostly the dynamics and alignments and the geometry. And then we can make sure, okay, what is our problem? Can we make big data of it? And then we can focus and steer directly on that typical spot to do the maintenance. And that will save a lot of time, but also costs. But now, in the old-fashioned way, you could say we only focus on the corridor, and when the corridor says, okay, we have sinking track, then you do the full corridor. And that's a waste of money, so that's what we try to do. Last question of today was about, I saw typical questions about what are the regulations for a swing nose in a long switch, for example, and what are the regulations for all kinds of other things. And I have to explain two ways. One, you have the TSIs, that's European-wide, and maybe in other parts of the world we also have this general, you could say regulations, but mostly you have to find your regulations in your own country. And that's because of history. So please, when you like to know something about what is allowed and what is not, go inside your own regulations in your own country, and let's have a discussion next time. What is coming out, and put your results on the forum so we have a nice discussion with each other. So good luck. So thank you. I see that you are coming up with nice topics. I do my best to give as much feedback as I can. Hopefully this will help. Hopefully you get some more enthusiasm to go put your questions on and also have more interaction with each other. So when you have practical problems for your own country or from your environment or your working area, feel free, put it on the forum, use the AskProf for next time, and keep on track. Thank you.